Good morning, guys. So we're going to be graphing trig functions. We're going to go over like a few concepts and then do some simple graphs without transformations, and then we'll do a worksheet, a few problems on a worksheet with transformations. Okay, so basically for graphing trig functions, the equation is y equals a. Let's just use sine for this, but this would be the trig function or whatever it is. So x minus h plus k. So this is the equation. Y equals a sine b parentheses x minus h plus k. So let's draw a graph. Basically, I'm just gonna draw a random graph. Okay, so here we have our plane, y and then x, and so the amplitude, which is a, is like, it's not like it's kind of like our slope. Basically, it stretches our graph, or it vertically stretches our graph if it's above 1, and if it's under 1, then it flattens it. So this would be like our amplitude. If it doesn't say anything, then the amplitude is just 1, max is 1. But if it's like 2, then instead of the max being 1, it would be 2. And instead of the min being 1, it would be -2. Yeah, and so let's say this point here, this would be like hk. So if in the equation it says like if it said like theta plus pi over 4 in parentheses, this is your transformation about the x-axis, and you do the, so that's the h part, and it does the opposite. So if it says minus, instead of going to the left, you would go to the right. And if it says plus, instead of going to the right, you go to the left. We'll do practice ones later. And this is a graph of sine. Okay, so you have your period, which is 2, the period is 2 pi over b. So that basically tells you where the intercept is for sine, and then where the max is for cosine if it's positive. But if the graph is negative, it's basically you put your negatives there. Yeah, we'll do some practice. But that's that. Yeah. K is like the average value. So it's halfway between the max and the min value of the function. So this is a like bad graph, but say this is our like intercepts, and you have the max here, or the min here and the max here. This is like halfway in between. Yeah. Okay, anyways, let's do some practice. So let's say we have y equals y equals 2 sine pi over 2 x, or x can be inside or outside, we'll put it there. So we see here the amplitude is 2, so I'll write a equals 2, and a, it's the absolute value, so the absolute value of a is the amplitude. Okay. So amplitude is 2 right here. And let's figure out our period. So the formula for the period is 2 pi over b. And here our b is pi over 2. So 2 pi over b, 2 pi, it's going to be divided by pi over 2, which is the same as multiplying by the reciprocal. And that gives you 4, because that cancels out. So our amplitude is A, and our period is 4. Okay, so knowing that, let's draw a plane. So there is no shift here, and we know sine, one of the intercepts is at 0. So we're going to draw one at the origin, and then the period is 4, meaning that one thingy will end at 4. So 1, 2, 3, 4. It's going to end here. So there's like a few different ways to graph it, or to remember how to graph it. Some people use like the acronym like MIMI or iMIMI, but I don't use that. So I basically, for sine, I would draw a dot at the minimum, or where the period starts and then where the period ends. And then I'll plot the middle point. This is also a bad graph, but I'll plot the middle, which is like here. And then basically I'll figure out the maximum from there and draw the graph. So I don't use the acronym. So that's how I do that for sine. Then for cosine, which we'll do in a second, I'll just draw the start and the end at the maxes, which we'll do after. Anyways, so our amplitude is 2, which means our graph is being vertically stretched by a factor of 2. So instead of this thing being 1, it's 2. Right? So that's our max is 2, and our min is -2. So you start here, and then you go up. That's basically our graph of y equals 2 sine pi over 2x. Okay, let's do another example. Let's get this over. Okay, so y equals 2 cosine pi over 2. So this is the same thing, just cosine. So there's no need to calculate period or amplitude again. It's just going to be the same as over here. Only thing that's different is this time it's cosine, not sine. So basically for cosine, I'll draw the starting point, which there's no transformation about the x-axis here, so it's just going to be at 2. So it doesn't move from 0 on the x. And then the max is just going to be 4, because we calculated that earlier, and I draw it at the max. And then the halfway point, which is 2, is going to be our min, and the intercept is going to be half of that. So you have this graph for this one. Okay, so let's do another one. So let's do y equals 2 cosine half x. So the amplitude is 2. So I like to identify the amplitude and the period first. And then you have 2 pi over b, which is 2 pi divided by 1/2. That would be 2 pi multiplied 2 over 1, 4 pi. So our period is 4 pi. So you have pi, 2 pi, 3 pi, 4 pi. Amplitude is 2, so max 2, min -2. And for cosine, I draw starting in endpoint at the max, midpoint at the min, and then draw. Oh, draw. Okay. What? Okay. There's our graph. Let's do another one. Y equals 2, 3 cosine 2x. Amplitude is 3. Period is 2 pi over b, which, hold on, my writing just keeps messier and messier. What did I write? Okay, that's a 3. 2 over 2. Okay, our period is pi. So, okay. Usually you would break it into intervals of 4 for the period, or identify each quarter as it leads up to the period pi, because there are like 4 points. There's like 1, 2, 3, 4, like that you need to most accurately plot your graph. So I like to do a period, and then what is this? Pi over 2, and then yeah. Okay, so max min is gonna be 3 because our amplitude is 3 in this case. So our graph is gonna, hold on. Our graph is gonna look something like this. Yeah. Okay. Okay, do another one. Okay, let's do y equals 2 sine half x. Identify amplitude, which is 2, and period is going to be 2 pi over b, which is 2 pi over 1/2, which is 4 pi. Okay, so period is 4 pi, so 4 pi split in half. Okay, so for sine, I draw it at this chart, and the middle, max min, and you have a then you have a graph. That's the graph for this. And let's do a few negative ones. So let's see. Let's do a negative cosine one. So you have y equals negative 2 cosine pi over 2x. Amplitude is negative 2. The period is 2 pi over pi over 2. 2 pi over 1 times reciprocal. Yeah. So basically, before we would draw, I'll draw the parent one. Before we would draw the starting point and the ending point at the max, but this time we're going to draw it at the min. So you're going to draw it at the min. Yeah, so this is the graph. The navy one is the graph for this, which is negative. Let's do a negative sine one. So y equals negative 2 sine 1/2 x. Amplitude is -2. Period is 2 pi over 1/2. 2 pi times 2 over 1. Period is 4 pi. So basically, I still draw at the start and the end first, and instead of going up first, like that, oh wait, I should have kept that. Okay, and then I'm gonna go down first. So instead of going to the max, I'm gonna go to the min, and then I'm gonna go to the intercept, and then I'm gonna go to the max. So now you have that. This is a really bad graph. It's supposed to be smooth, but yeah, you get the idea. And if I were to actually no, I'm gonna put transformation ones in another video. But where's my other thing? Yeah, we'll do tan ones in another video. But yeah, so short review, the amplitude is it vertically stretches or compresses the graph. So if I had if I had a graph, and so let's do y equals sine x, so just the regular one, it would be oh wait, no, okay, it would be like that. Oh my, something like that. And then I have y equals 2 sine x. It would be double this. So the length is doubled. And if I had y equals 1/3 sine x, it would be hold on, it still intercepts at the same point. So it's 1, 2, 3, basically. And then if we had cosine, right? So just the parent, the regular, y equals cosine x, you have here, right? So wait, I should have made it smaller. Okay, so something like that. And then I have y equals 2 cosine 2x. Then it would be, oh wait, hold on. What am I doing? 2 cosine x. It would still intercept at the same point, but it's doubled, right? And then same idea. If it was y equals 1/3 cosine x, then it would be flattened. Hold on, what? It would be flattened. Yeah, okay, and let's talk about review on period. So y equals cosine x. I don't know. Oh, just draw something. Okay, and then y equals cosine 2x. That changes our period, and so it's gonna like, it kind of looks like it gets, I don't think you would call it vertically compressed, but wait, let me draw it. It would be like, that's really bad graph. But say the regular one's like this, it's just gonna go like, it's gonna be skinnier. Yeah. And then if it's, say y equals cosine x over 3, it does the opposite that the amplitude does. Wait, no, it doesn't. Just kidding, it doesn't. It just makes it like wider. So say this is like less than 1, it's gonna like, wait, let me draw first. Where's 3? So let's just like pretend, I don't know where 3 pi is. Where would 3 pi be? It would be like at the end of this period. Where would that be? It would be like here. Okay, and then this would be like here. Y equals cosine x over 3 would be like, that. Yeah. So I don't know if any of that made sense, but that's kind of the idea of graphing trig functions. And then part 2 will be more / harder examples. Yes. So see you in the next one. Bye.